IP-based storage. iSCSI, okay, or NFS we're talking about here. Okay. We know that it can be less expensive to deploy these solutions instead of fiber channel for all the reasons listed here, and we don't need to rehash that. That's a pretty standard thing. We know that these IP-based solutions are fully supported by VMware ESX, so we can do software iSCSI, we can do hardware iSCSI, we can do NFS. Okay. We know that the iSCSI license is provided at no charge with the storage system. So these are all reasons why customers may want to move towards IP-based storage. I won't go into the quagmire of performance. That's a topic best suited offline. But keeping in mind, what are the design decisions or what are the consequences of making a decision to go with IP-based storage? Again, if we're looking forward at implementing VMware SRM sometime before NFS support gets added, then we're limited to doing iSCSI because we have to do block-based storage. Okay. Another thing important to remember is that when we start provisioning via NFS, provisioning new VMs in an NFS environment will create what we call thin VMDKs. Not necessarily the same as the thin provisioning we talk about on the NetApp storage array, but we'll create VMDKs that are only as large as the space actually required by the guest operating system. Okay? But the problem is, and there's a service request that's been filed, it's actually considered a bug in VMware. The problem is that if you perform a storage vMotion operation on those files, or if you clone those files, the result is a thick VMDK, a full-size VMDK. So you might go in and say, I'm going to create a VM and I'm going to give it a 20 gig VMDK, and I'm only going to install 3 gigs worth of data in it. Well, if you do that from scratch, that's fine. You'll end up with a VMDK that's 3 gigs in size. And the rest of it, it's allocated, but it's not actually used. As soon as you storage vMotion that VM, or you clone that VM, the clone or the resulting VM after you do the storage vMotion will be 20 gigs in size. Okay? So that thin provision status is not preserved. Yes, sir? Although it will re-thin provision once you run dedupe. Yes, you're absolutely right. And the comment was that it'll re-thin provision when you run the dedupe. And so you can get around that. If you run dedupe, then you're going to get some of those space savings back because that space is not being utilized. That's important to point out, and thank you, absolutely. Okay? But you don't want to necessarily go in and try and position IP-based storage on that basis alone. Okay? So the other thing that you may find when using IP-based storage is that you may have to do a bit more upfront design work than you might have anticipated. Okay? The reason being, as soon as we need to scale beyond 1 gig, assuming we're using 1 gig here and not 10 gig, because not everybody can afford 10 gig yet, as soon as we need to scale beyond 1 gig of throughput from an individual ESX server to the storage array, then things start getting complicated. We either have to look at, number 1, cross-switch link aggregation, or number 2, multiple VM kernel ports. This is just kind of how VMware ESX is today. Okay? I can give it 2 NICs for an iSCSI VM kernel port or an NFS kernel port. Okay? But without link aggregation, it's only going to use one of those. And if I am using link aggregation but not using cross-switch link aggregation, then all my links have to go to the same physical switch. And I've now created a single point of failure because that one physical switch could go down. Okay? So I have to look at cross-switch link aggregation, which is supported in the newer hardware or the high-end hardware, like the 6509s with the Supervisor 720 modules and VBS virtual blade servers, or Catalyst 3750s. Some of the other vendors might offer products as well. I don't know them quite as well. That would actually allow us to take that link aggregation and spread it across multiple physical switches. At that point, then I'm protected from a switch failure, and I can take advantage of multiple links. If I don't have cross-switch link aggregation support, then I have to draw back to multiple VM kernel ports. And those multiple VM kernel ports have to be on different IP subnets. If they're on the same IP subnet, ESX will only use one of them instead of both of them. Okay? In either case, whether I use cross-switch link aggregation, if I use regular link aggregation with a single switch, because I think that switch it's a big chassis switch, and I'm not, I'm comfortable that it's not going to fail. Or I use multiple VM kernel ports. In either case, we need multiple storage targets to actually use that bandwidth. Okay, we'll have to have multiple iSCSI targets. We'll have to have multiple IP addresses with NFS exports, in order to actually be able to take advantage of that additional bandwidth. So it may be a little more complicated up front on the network design than perhaps you might at first think. Okay, questions? All right, so how do we go about